So welcome to lesson 3 of analytic geometry in our series of 6 lessons about how to perform geometric calculations on the coordinate plane. Today we're going to focus on how to find area and perimeter of two-dimensional figures on the plane, such as triangles, rectangles, and other quadrilaterals. So the first thing we need to know is a little bit of review of vocabulary to do with perimeter and area. So in order to calculate the perimeter of a shape, we want to find the length of each side and add those sides together. To find the area of a shape, we are looking for the number of unit squares that fit inside that shape. So for example, if we're finding the area of a rectangle, we are doing the length times the width to calculate the number of small squares inside that shape. If we are finding the area of a square, we are finding one side times the other side, which would give us side squared. It's a little bit more complicated in a triangle and a circle. In a triangle, the formula to find the area is that we do base times height. Notice that perpendicular relationship between base and height. And the reason we take half is because we're just looking for half of the area of that base times height rectangle. So area formula for a triangle, 1/2 base times height. For a square, base times height or side squared. For the rectangle, length times width, sometimes written as base times height. And then the area formula for a circle is pi r squared, which we did review in that last unit on circles. The most important thing to keep in mind when we are finding the area of a shape is that the base of the shape and the height of the shape must be perpendicular to each other. So we are always looking for this base-height relationship where the base and the height are perpendicular. So we're going to keep that in mind as we go through this lesson. So let's just make sure that we have that detail down. Again, super important. The base and the height of a figure must be perpendicular. So let's take a look at these next shapes. We're going to highlight the base and the height. I'm going to highlight the base in yellow, and I'm going to highlight the height in green. So for a rectangle, it really doesn't matter. We can make this the base and this the height, or we can do it the other way around. We can make the yellow one the height and the green one the base. It doesn't matter how we orient that rectangle, the shape will have the same area. In our right triangle here, again, the base and the height are perpendicular. So this is the relationship that we are looking for between base and height. It gets a little bit more complicated when we have shapes that aren't square to the grid. So I am looking here for our yellow base is down at the bottom here, and then our height, maybe it could be this one, maybe it could be this one, maybe it could be this one. We are looking for this perpendicular relationship between the base and the height. We need those to be perpendicular. And our last one, I'm going to choose this to be the base, which means the height is going to be perpendicular. Again, those base and height are perpendicular. So to calculate the area, we're going to need to know what's the length of the base and what's the length of the height. So on the next page, we have a couple of examples of finding area of shapes. So the first shape that we have is a trapezoid. And in order to find the area of a trapezoid, we would use our MCAS formula sheet, which you would be allowed to use on MCAS and additionally on any test that you might take in a future geometry class. So if we look down on our formula sheet, we see that the trapezoid formula is here, that the area is 1/2 times height times the sum of base 1 and base 2. So the first thing I'm going to do is highlight my bases in yellow. Remember, the bases of the trapezoid are the parallel sides, and the height is the distance between them. And notice again that I am looking for that perpendicular relationship between base and height. So in order to find base and height, I am going to have to calculate the length of each of these sides. So I'm going to use the Pythagorean theorem to do so. And let's start with the shorter base. I'm going to call this one base 1. So to find the length, I'm going to go up 3. The change in y is 3. And the change in x is from -2 to 4, so that's 6. So I have 6 units here, 3 units here. So my change in x is 6. My change in y is 3. So I have the square root of 36 plus 9, which is the square root of 45, and I'm going to write that in simplified terms. That's the square root of 9 times the square root of 5, so that's 3 roots of 5. To find the length of base 2, again, I'm finding the change in x and the change in y. So from -4 to 8 is 12 units horizontally, and from -1 to 5 is 6 units vertically. So my change in x is 12 units. My change in y is 6 units, which gives me a length that is the square root of 144 plus 36, which is the square root of 180. And I know that 180 is the square root of 36 times the square root of 5, so that's 6 square roots of 5. And then finally, I need to find the height of my shape, of my trapezoid. And the height of my trapezoid is this segment from WN here, and it looks like vertically my height is 4, and horizontally it's 2. So that means that my change in x is 2, and my change in y is 4. So the distance between n and w, that's the length of my height, is the square root of 4 plus 16, which is the square root of 20. And to simplify that, I get the square root of 4 times the square root of 5, so that is 2 square root 5. So I have now found how long is my height, how long is each base, and I am ready to fill in my formula. So my area is 1/2 times my height of 2 root 5 times the sum of my bases, 6 root 5 plus 3 root 5. I'm going to combine my like terms in parentheses here to give myself 9 roots of 5, and then I have half of 2 root 5 times 9 root 5. Remember, with multiplication, you can do whatever order you want. So half of 2 is 1. Square root of 5 times the square root of 5 is 5 times 9, which means that the area of my trapezoid is 45 square units. Finally, I'm going to go back up to my figure and make sure that that makes sense. If each one of these little squares is 1 unit square, is it reasonable that 45 of those are inside this shape? And that seems pretty reasonable to me. There's 5 units right there. It seems to me like 9 groups of that is a reasonable area for the shape of my trapezoid. And for today, we are actually going to skip finding the perimeter because we're going to find the perimeter on the next problem. So skip finding perimeter on this one, and you will find the perimeter on example 2. In our next example, we are trying to find perimeter. So again, perimeter means that I am looking for the sum of all of the side lengths. So I'm going to add up AB, BC, CD, and AD, and that will give me the perimeter of my quadrilateral. Okay, so I am going to start with AD just because it's a nice easy count. It's a horizontal line, so I can just count that it goes from -4 to +4, so AD is just 8. For AB, I'm going to have to use the Pythagorean theorem. So I am going from an x value of -4 to -3, which makes my change in x 1, and I'm going from a y value of -3 to +2, so my change in y is 5. So I have 1 squared plus 5 squared, which gives me the square root of 1 plus 25, which is the square root of 26. Next, I am going to find the length of BC. My change in x brings me from -3 to 2, so that's 5. My change in y is 2. That brings me from 2 to 4, which means that the distance between those 2 points, using that distance formula or Pythagorean theorem, is 25 plus 4. Take the square root. That gives us the square root of 29. So 26, a little more than 5. 29, a little bit more than the square root of 26. So closer, a little bit closer to 6. And then our last segment here, CD, has a change in x that takes us from 2 to 4. So my change in x is 2, and my change in y is from 4 to negative 3. So that's 7. So this is my longest side. That's the square root of 4 plus 49, which is the square root of 53. So my exact answer here, since none of these square roots simplify, is 8 plus the square root of 26 plus the square root of 29 plus the square root of 53. To approximate this, I would say probably use a calculator. I would get 8 plus a little bit more than 5 plus a little bit more than that. Square root of 53 is a little bit more than the square root of 49 is 7. And the square root of 64 is 8. So I would say that that's, I don't know, about 7.3. So without a calculator, I would guess that that's 10 plus 15, 25.7 is my guess. And now I'm going to check it in a calculator to make sure. And when I do plug it in, I actually get 25.76, which is pretty good. So in our last example, we are actually going to find the area of a circle. However, we did skip this particular skill where we graph a circle given the equation. So I'm just going to graph the circle for you, and then we will find the area. Okay, so we're all graphed. Some of you may remember from reviewing some algebra earlier in the year that the method we use here is called completing the square. But really what we're interested in today is getting the information from the picture that we need in order to find the circumference and the area of the circle. So my formulas are that the circumference is 2 pi r and the area is pi r squared. So you'll notice that the only parameter here that we need is actually the radius. So I need the radius of this circle, which we have as 5 from our equation, or we can count as 5 on the graph. So I know now that my circumference is going to be 2 pi times my radius of 5, which is 10 pi. And that's called the exact form. If you want to approximate it, you can multiply 10 by the pi button on your calculator, which is approximately 3.14. So that would give you approximately 31.42. And to find the area, the formula is pi r squared. So that would give us exactly 25 pi. And if you plug that in your calculator with the pi button, you would get approximately 78.54. So just as a reminder, our objective today was to find the perimeter and the area of polygons and circles and compare their distances to solve problems. You are now ready to move on and practice making these calculations to find perimeter and area yourself.